have talked about time series analysis. In this time series analysis, we have gone through what exactly the time series is and how it can be treated, how you can get exactly what time series is. In a general format, what we understand is any bivariate data in which one of the variable is fixed to be time and another variable varies according to the time, we can treat it as a time series analysis data. I'm trying to recap everything just because of there was a plenty of time in between the last lecture and this lecture. Let us go through very speed. Introductory part, we have seen it in the times meaning of time series. That is what we already seen. Definition: set of data representing time is called time series. We have talked about its utilities. Components. There are 4 components in a time series. One is called trend, or you can say secular trend. Both of them are being denoted with T: seasonal variation, cyclic variation, and irregular variation, among which we have studied it in detail. What do you mean by secular? What do you mean by seasonal? What do you mean by cyclic or an irregular? To make it a recap, secular trend is general trend. You can say that by all mean, if trend can be divided in 2 parts, initially this component can be divided in 2 parts. One is called long-term trends, or you can say a short-term trend, or you can say component. Among this long-term and short-term, naturally it is being associated in terms of time. The trend to be observed having a long-term time, it is called long-term component of time series. Among these 4 different variations or 4 different components of time series, secular trend is a long-term trend. Long-term trend in the sense it is to be observed with more than 7 years, 7 to 10 years, more than 7 to 10 years. If you observe a trend, then it is called a secular trend. If it is connected with, if you just try to describe it or differentiate it in terms of time. Seasonal variation. As the name suggests, seasonal variation means variation which is according to season. Generally, these seasons are within a year. There are 4 different seasons according to our tendencies. There are 4 different seasons. So naturally, seasonal variation is within an year. If it is within an year, so naturally it falls under the short-term component of time series. Cyclic variation. Cyclic means there are, you might be knowing it quite well, or we have already discussed it earlier even. Cyclic means it is a cycle, short of a cycle. After a certain business cycle or after certain cycles, you may observe certain variation. They are called cyclic variation. Okay. When you say cyclic variation, that means note, it is not being restricted to an year only. It can be more than few years. More than few years means again the 7 to 10 year is a key there. So again it falls under long-term time series. The 4th one is an irregular variation. Irregular variation is a variation, you can say that it comes under with massive way. Natural calamities are there, or there are few government policies change drastically. At that time, whatever variation you observe, it comes under irregular variation. Okay, naturally this irregular variation comes under the tag of short-term trend, because as you know that this can happen in a year, within a year or so. So among these 4 components, 2 of them are tagged as long-term and 2 of them are tagged as short-term. Secular trend and cyclic trends are defined, or you can say they are treated as long-term trend, whereas seasonal variation and irregular variations are treated as short-term trend. right? Okay, let us see the next one. We have discussed it. What do you mean by secular trend, linear trend, seasonal variation, cyclic variation, irregular variation? Okay, now these are the four different components. When I use a word, it is not classification, it is component. When I say it is component, at that time, naturally, the combined impact of all these four components becomes a final trend. So naturally, here two different models are used. As far as examinations are concerned, you are not much, you should not get much worried about this model. There are two different models which we can use. One is additive model and second is a multiplicative model. The difference among these two is, if you denote it with T, trend means T, seasonal variation is being denoted with S, cyclic variations are denoted with C, and irregular variations are generally denoted with I. So there are four components, T, S, C, and I. If you just make addition of all of them, that means final trend. Final trend is if T plus S plus C plus I, it is nothing but you are using an additive model. Another model is multiplicative model. In a multiplicative model, instead of adding it, if you just multiply each of them and you get final trend, that means you are using a multiplicative model. You can observe it this way. Final trend denoted with O. O is equal to T plus S plus C plus I. This means this is what an additive model is. Additive model is used to get some other, by making some plus and minus left hand side and right hand side, you can get impact of all other trends even. Like O minus T, which is, we have taken just T on left hand side, so it becomes O minus T, and right hand side it would be S plus C plus I, something like that. In short, this is what the beauty of this model is. Similarly, the multiplicative model is nothing but it is a multiplication of all four components. T multiplied by S multiplied by C multiplied by I. That means it is TSCI becomes the overall component. Similarly, in the last slide, we have seen it that it was O minus T. Instead of, naturally it is a multiplication, here it comes in a denominator. So O upon T is nothing but SCI. O upon TS becomes CI. O upon TSC becomes I. I means irregular. Irregular variations are always difficult to measure. So you may have some other mechanism to get that irregular variation. And this is how you can get it with multiplicative model. You don't have to bother much about it, as you have to simply remember there are two models. One is additive model, and second is a multiplicative model. We are not much bothering about which model is to be used in this case, right? Let us go further. Now, first thing first. First of all, we are concentrating it on secular trend. To get this secular trend or to measure this secular trend, that is what our prime focus is. To measure this secular trend or a word trend, whenever a word trend is used, it reflects secular trend. Secular trend is generally denoted with that T, right? There are four different methods to evaluate, to measure the secular trend. Okay, which four methods are there? The first method is named as freehand curve method, or you can use another word, graphical method. Both the words are same. Freehand curve in the sense that freely you can draw a curve, connect the points, connecting the dots, whatever you may get, that becomes a graphical method, or you can say a freehand method. The second method is named as semi-average method. Average, you might be knowing it. This is called semi-average. How it is affected, how this term is used, and how to measure it, that we'll see it in the next slides. The third one is moving average method. And the fourth one is least squares method. These are the four different methods by which you can evaluate or you can measure secular trend. First thing first of all, let us concentrate on this freehand curve method. In this freehand curve method, you don't have to worry much about it. But at the same time, here graph paper is to be used. There are few steps to be done. There are few fixed steps. Fixed steps in the sense, always take time on x-axis and observation on y-axis. Take a graph. On a graph paper, always your x-axis is fixed to be on time and y-axis is fixed to be your observation. Observation means the another variable which is given to you. Okay, this is a simplest method. One should draw a graph if this graphical method is to be used. Now let us see how it works with one of the example. Look, the question is like fit a trend line to the following data by freehand curve method, or you can say a graphical method. First of all, what you are likely to do is just make a graph paper, draw a x-axis and a y-axis. On an x-axis, time is to be fixed. On a y-axis, naturally, all the observations. In this case, it is production. Production in thousands. So this production is to be plotted on y-axis. Okay. Once you do it, just observe the data. In a data, the first variable is year. 2001, 2002, 2003, 4, and so on, up to it is 2010. Fine enough. So the lowest value is 2001 and the highest value is 2010. Naturally, on an x-axis, the first point should be started, it should be 2001, and the last point you should have on x-axis is 2010. The increment is of 1, so there is nothing to worry of. 2001, 2, 3, 4, and so on. Put all the points on x-axis. Generally, you can do it because as such, every one of you are comfortable with drawing a graph, I suppose. The second thing to be concentrated on is production. Production, a liquid form of a data is given 150, 55, 65, 52. Just mark the lowest among it. The lowest among it is 150. Fine enough. The highest among this is 180. So naturally, all the points you should be plotting it on a graph paper on y-axis should consist the lowest to highest, right? So the first point to be put on y-axis should be 150 at least. So we have started it from 150, 155, 160 with a difference of 5. Since all the figures are in thousands, so it is difference of 5,000. 150, 155, 160, and so on. Now, the first thing is to be done is plot all the points on a graph paper. While plotting it on a graph paper, naturally this is nothing but x and y now. Your x is 2001. 2001 point comes somewhere very near to 0. In this case, x-axis 2001 and y-axis 150. Put a dot mark there. Fine enough. 2002. Naturally, it is the next point. 2002, put a point against 155. 2003, put a point at 165. 2004, put a point at 152. Similarly, plot all the points. Look, all these points are in a zigzag form. Zigzag form in the sense, try to connect each of them. Naturally, while trying each of them, you will find a zigzag mechanism. So 150, the second point 2002, third point 2003, 4, 5. It may look somewhat like this zigzag. This is called a zigzag. Okay, among these points, we have to draw a line which is a best fitted line. Best fitted line means it should be exactly in between of these points. So just draw a line which is half of the area covered should be upper side and half of the area covered should be on a downward side. So draw a line, and that line is called trend line. Now you just observe the same line is drawn here. So this line is called a trend line. Now, by observing this trend line, what you can observe, look, your trend line is going from left hand side corner to right hand side upward corner. Is it right? So naturally it is in an increasing form. Since it is in an increasing form, it goes upwards, we can say that it's a upward trend. Yes, Payal.
Yes, sir. Why you wrote 2001 there below the zero? Like the 2001 should be there in place of 2002. We are,
That is
we
all
can't
fine.
start.
You can look. Your starting point can be anywhere, right? Because when you instead of putting it as a origin means at a 0, 0, you can put it at 2000 wherever 2002 is there. You can put 2001 there. It is all fine. You don't.
Okay, okay.
You're. That is up to you. You have to decide it. Since the number of points were more, so I kept it there.
Okay,
It
sir,
is
got
that
it.
simple, right? You can put it right hand side. Even wherever 2002 is there, you can start it 2001 from there, and you can extend your line right hand side 1 point. It is absolutely fine. Clear?
Yes, sir, clear.
Okay. So this is how this trend line is drawn. While this trend line is drawn, that is not all over. You have to observe the trend. When you observe the trend, since it is going from downward side to upward side, from left to right, naturally you can say that it is an upward trend. Is it fine? Okay. There are second possibility. It can go from left hand side upper corner to right hand side down corner. Then your trend line may be somewhere in exactly in a reverse form. If that is in a reverse form, you can observe that your trend is downward. And if this line, the line which you are drawing, it is parallel to x-axis, then you can say that there is no trend within the variables. Means it is consistent, it is constant. Right? These are the only three possibility. It may go upward, it may go downward, or it may remain constant. When you say remain constant, there is no trend. If it goes onward, it becomes upward trend. If it goes downwards, it comes to a downward trend. Fine. Now, can you list out what are the plus and minus of using this method? Look, this method is very simple. First thing, if you just take it a plus, this method is very simple. Second, there are no formulas used in this method. Third thing is, you can get a direction of trend. You are not getting this trend numerically. Here what you can observe is simply the direction. Direction means, is it upward, is it downward, or is it consistent? These are the only three possibilities while observing trend through graphical method. Can you say what are the negative points in it? What are the negative points in it? Can anyone say? Yes, Payal.
Exact measurement.
Pardon?
Exact measurement cannot be found.
Very simple. Exact measurement cannot be found as such. For a moment, let us suppose this is a class going on right now, and if I ask you to have the similar data and I ask you to draw a line, naturally The same line may occur, may not. Someone may feel that this is the best fitted line. Some other person can think of that this line is perfect. The third one may think of some other line. Ultimately, result is not going to affect. It is going to be upward trend for sure. Means ultimate conclusion will not affect. But at the same time, line drawn by each of you may differ. Whenever we talk about mathematics and statistics, it should be with a perfection. So that perfection is not here. That perfection is not fulfilled right now. Your answers are not getting altered, but at the same time, each of the line may differ. So this method is not much used in practice. It is just because of it is more dependent on the person, or you can say statistician, that which line he may draw. I may find this line is a perfect line. You may think some other line. Third person can think of some other line. Every line may go upwards because it's a data. That is absolutely fine. But thing is, every one of you are not getting a similar kind of line. That is why this becomes a limitation. It is highly subjective on personal judgment. Every person may judge it differently, so it is very much, you can say, it is subjective and it is based on personal judgment. Ultimately, your result, your prediction may not get altered, but at the same time, if your data is such that consistent trend and a trend line, if they are very near, then your prediction may go wrong. When the consistent line and a downward trend line is very near, then your prediction may fail. So these are the limitation of this method. So this method is not much used in practice. Is it clear?
Yes, sir.
Oh,
Yes, sir.
fine.
Yes, sir.
Can we shift to another method?
Yes, sir.
Okay,
Yes, sir.
fine. I suggest all of you to have practice. Practice in the sense, just take some of the data and put it on a paper and try to get this trend line. You will practice it, so it would be better for you. You will get exact idea about it. The merits and demerits, the method is simple, method is flexible, no mathematical formula is used, and this method is also used for forecasting about future. You might be a little bit surprised about it. This method is also used for forecasting about future. How you can forecast the future with this. And coming back to this method, let us suppose we want to forecast it for 2011. Which is the next point. The last point was 2010 and the next point would be 2011, right? Okay. If you just extend your line onwards, whatever point comes against 2011 and then whatever point comes exactly opposite to that 2011 point on y-axis, that can be the prediction of production. Most probably, if I'm not mistaken, you might have done it with regression analysis even, but that prediction may not be that perfect. The prediction which I am getting might not be as same as the prediction which you might be getting or your friends might be getting. So naturally you can predict it, but even though that numerical prediction may not be that correct, because everyone draws a different line, so naturally there would be a limitation of everyone's instincts. So this method is not that good, but you can forecast the future. The demerits of this methods are subjective, they are judgmental, lack of accuracy, and long run movement obtained from this method is not defined. This is because number of curves can be fitted from the same original data. In an examination, if they ask you what are the merits and demerits, this is how you have to write it down, right? Okay. Shifting to the new method, semi-average method. This semi-average method, we are dividing it, or we are classifying it into two different situations. In this two different situations, in the sense the total data set given to you, are they number of observations are even or they are odd? When the number of years in a time series given is even, then I say even, that means 4, 6, 8, 10, 12, means even number. Even number of observations are given to you. At that time, a specific methodology is used, and if odd number of years are given to you, you have to use some other way out. Right enough? Okay. When I say number of years in a time series given is even, look, whenever the even number is there, you can divide that numbers in two parts, because a number which is divisible by 2 is called even. So if an even number of observations are given to you, you can divide it in two different parts, the first group and a second group. Fine enough? You can do it that way? Okay. Now let us take one of the examples that will make it more clear. Look, fit a trend line by the method of semi-average to the following data. 2000, 2001, 2, 3 and so on up to 7. Look, 2000 to 2007. How many observations are there? There are 8 observations. 8 is an even number. Since this 8-year data is given to you, 8 is an even number, you can divide it into two different points, two different groups. Okay. 2000 to 2003 becomes the first group, and 2004 to 2007 becomes the another group. Right enough? Okay. The data given according to this time is of sell of some company in lakhs. Fine enough. Put it in a two different column. The first column is year, second column is sell. Now make a group. While making a group, naturally, first 4 years and the last 4 years. Okay. Make a sum total of first 4 years and make a sum total of the last 4 years. So the first total is 412 plus 438 plus 444 plus 454. Well, you make a sum of these 4 entities, it comes to 1748. Similarly, if you just make a sum total of remaining 4 years, 470, 482, 490 and 500, the sum becomes 1942. Is it clear? Okay.
Yes, sir.
Then after, get an average. Naturally, since we have summed 4 different elements, this 1748 is to be divided by 4. So that becomes 1748 divided by 4 becomes 437. And what would be the middle point in a year? 2000, 2001, 2002 and 2003. If you make a sum of each of them, divide it with 4, it comes to 2001.5. Is it right? So now you are getting two different points, 2001.5 and 437 for the first group. Do the same for the second one. While making a sum of all these 4 elements, 470, 482, 490 and 500, it comes to 1942. Divided with 4, it comes to 485.5. And now year part, 2004, 5, 6 and 7. Make a sum, divide it with 4, it comes to 2005.5. Yes, Dikshita, please.
Sir, that last column for middle year, can you please explain it once again?
Middle year is nothing but, look, the first point is 2001.5, right? Which is nothing but 2000 The thing which you did with cells, do the same for year. 2000 plus 2001 plus 2002 plus 2003. There are 4 elements. Make a sum of each of them, divide it with 4, what you will get would be 2001.5. The process which you are doing with cells, the same process is to be done with year. Similarly,
Yes, sir, got it.
2004, 2005, 2006 and 2007. Add each of them, divide it with 4, what you will get would be 2005.5. Clear?
Yes, sir.
Okay, let us go further. Vijayeta, please.
Sir, it is compulsory to find out the middle year also.
It is just because of you have to plot it on a graph paper where you will be plotting it in any case if you are not getting it.
Okay.
If you don't make a middle year, what will happen? Where you will be plotting these points? You have to plot these points on a graph paper. Since you have to plot it on a graph paper, naturally you require coordinates. Coordinate means x-axis, point on x-axis and point on y-axis. Since you have got this semi-average point, naturally it was related to a variable. It comes on y-axis. Years are generally on x-axis. So where you will be plotting this 437 or 485.5, naturally you need a corresponding point. That is why this middle year is very much required to find. Then only you will be able to plot it on a graph paper. Is it clear?
Okay, sir. Got it.
Fine. Now, what to do once you get it done? First thing first. Look. Again, the same thing is to be done. First of all, take a graph paper. On a graph paper, since your year is starting from 2000, so 2001, 2, 3, 4 and so on up to it should be on x-axis. Similarly, in a data set, you might have observed that, just observe it. You might be observing it that the lowest value which you are having is 412. The largest value which you are having is 500. So from 412 to 500, it should be plotted on y-axis. So we have started it from 400, 420, 440, 460, 480 and 500. This is how this axis are to be defined. Right enough? Okay. The next thing is to be done is, first of all, you don't have to bother much about anything. First thing is to be done is draw an actual line. Actual line means actual parameters or actual values are to be plotted. The first value which you are having right now is, I'm coming back. The first point is 2000, year 2000, and the cells is 412. Okay, that first point is to be defined. So x-axis 2000, y-axis 412. You can dot a point at 412. Similarly, the second point, similarly, third point, and each of the points are to be plotted on a graph paper. This is an actual line. Actually, what point says, that is what you have to draw it initially at a first point. Once you take all the points, then after this semi-average method is to be used. Now, try to plot these 2 points. This 2 point in the sense 2001.5 against 437 and 2005.5 against 485.5. Try to get these 2 numbers on a graph paper. Look, this is what this point is. And those 2 points, now you have only 2 points. These 2 points are to be connected through line. Draw a line connecting these 2 points. While connecting this 2 points, you will get a line, and that line is called trend line. Now this trend line is going from left hand side corner to right hand side upper corner. So trend is positive, or you can say it is an upward trend. Similarly, it may happen in a reverse form. Reverse form in the sense it may from left hand side upper corner to right hand side lower corner, then there would be a downward trend, or you can say a decreasing trend. So you may get that line which is from upper right hand corner, left hand corner to lower right hand corner. So it goes downward. So your trend would be downward trend. Is it clear now? Hopefully it is clear. Have you noticed one thing? That the limitation of graphical method, that everyone was in a position to draw different line, we have tried to overcome it. We have tried to fix it. Now you have, using this semi-average method, we are getting 2 different points by making a group of 2, and these 2 points are to be done by connecting these 2 points. You will have a line. So now you don't have liberty to draw your own line. It is fixed. Now these 2 points are to be connected. So the liberty which you were having, that liberty has gone. We have tried to fix it. Since we have tried to fix it, this is more perfect compared to the last method. In a graphical method, everyone was in a position to draw their own line, whereas in this case, since some mathematics are included in this, so we have tried to fix that part. Right? So now I suppose if even number of years are given to you, you know how to draw a trend line. Clear?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Now let us see the other option. If we have odd number of observations with us, odd number of observations in the sense 5, 7, 9, 11 or something like that, then what will happen? Now in this case, the only difficult part is you cannot get 2 different parts. Exactly, you cannot divide the whole data set in 2 parts, because number of observations given to you are 5, 7, 9. Naturally, what should one do? Can anyone guess anything? Let us take example that would make it more clear. Fit a trend line by the method of semi-averages of the given data, 2008 to 2014. Look, how many observations are there? There are 7 observations. Since there are 7 observations, you cannot divide it in 2 parts as we did it in the last case. In last case, even number of observations were given, so you will be able to get it in 2 different parts. You can slice it in 2 different parts, whereas this is not the case. In this case, you cannot slice it in 2 parts. Then what should one do? Let us see. In this case, if the number of years or number of observations are odd at that time, look here, total number of observations are 7. So just try to divide it in 2. 7 divided by 2 is 3.5, right enough? Round it off. But, just 3.5 means make a group of 3. First 3 years and last 3 years. Naturally, one of the year will be left. That lefted year should be exactly which is in between of all this observation. that year is to be omitted. That year is to be omitted in the sense, among this 7-year program, or you can say 7-year data, make a group of first 3 years, make a group of last 3 years, and actually a year which is in between of both the groups, that year is to be omitted. Right? Baki, all the things are same. While making a group of 3, here it is profit given in thousands, 2008, 2009, 2010. So this 20 plus 22 plus 27 total becomes 69, divided by 3 becomes 23. And the middle year, here there is a mistake. It is not 1982, it is 2009. Similarly, in the last 3 group, it is 2013. There is a mistake. There is a typo mistake in this middle year. In this, the first case, middle year is 2009, and in the last 3 middle year is 2013. The middle year is to be omitted, right? Now, the same thing is to be done. Plot it on a graph paper. While plotting it on a graph paper, first thing first, x-axis fixed to be time, y-axis a variable which is profit in thousand, the lowest value to highest value on x-axis as well as on our y-axis. First thing is to be done is plot the actual data. While plotting the actual data, it may come to a little bit of zigzag way. That becomes an actual line, and you have to write that this is an actual line. What next is to be done? Naturally, there are 2 points which you have calculated: 2009, 23, 2013 and 33. These are the 2 coordinates which you have to put it on this graph paper, and you have to connect these 2 points. While connecting these 2 points, you have to draw a line, and that line becomes a trend line. Right? You have to omit, which is somewhere in between. A middle point is to be omitted, or else nothing is to be thought of. Do the same process as you did it in the first method. Right? So this is how this trend line is to be found. Okay. Secondly, there was a question that estimate the profit for the year 2015. Data of 2014 is given, and we have to predict what may happen in 2015. So look, as I said it earlier, that line which you are drawing, trend line, that is to be extended. One more point is to be drawn on x-axis, which is 2015, and try to draw a parallel line to y-axis against 2015. So naturally it is this point. That point is exactly where this trend line is written. Now draw a parallel line to x-axis and just observe where it gets intercepted on y-axis. 2015, draw a line on the graph paper and draw a parallel line and put a point on y-axis. Look, against this 2015, the point is 37. So you can estimate the profit of 2015 as 37,000. Is it clear?
Yes, sir.
I think it's absolutely clear now what is to be drawn and how it is to be done. So this is how this prediction may help you, and this is how you can make a prediction. Again, there are certain merits and demerits. Easy method, free from bias, trend values obtained are definite. Less time and effort is involved in drawing the trend line now instead of drawing it in a graphical method. Demerits are, this method is based on a straight line trend assumption which doesn't hold true always. For a moment, let us suppose your trend is not following a linearity. At that time, you cannot draw such line. This method is also affected by extreme values. This method also ignores the effect of cyclic variation, as we are fixing 2 points and we are connecting it, so no cyclic fluctuations are incorporated in it. So this becomes merits and demerits of this semi-average method. Right? Moving average method, we will see it in the next lecture. Until now, I mean, if you have any questions, floor is open for all of you.
Sir, when you will share this file?
When you
Will share this file because I want to write.
fine enough, I'll be sharing it. The PDF file, I'll be sharing it with you till date. Till date in the sense up to this. Up to moving average, you will get this PDF file in an hour or so.
Okay, sir. Thank you.
Right? I think this is enough for today. We'll have some further discussion in the next lecture. Thank you.
Okay, sir. Thank you.
Thank you, sir.